Hello, and thank you for joining us today for the Download Community Tech Talks episode 9. These are Tech Talks for the HPCC Systems community by the HPCC Systems community. We're going to start off today with a little bit of housekeeping, so please share today. So if you're on Twitter or any social media, please share with the hashtag HPCC Systems Tech Talks, and please also ask questions. There should be a tab, and please submit your questions. We will answer as many questions as we possibly can today after each one of our speakers. We'll also be asking polls throughout each presentation. And if you cannot see these for any reason, please exit full screen and refresh your screen, and you should be able to see them then. Also, we do welcome your feedback. We check these after each one of our Tech Talks. Please rate us before you leave today, and also visit our blog after the event for more information. And if you'd like to be one of our featured speakers, we would absolutely love to have you. Let us know. Reach out to us at techtalks@hpccsystems.com. At this point, I'm going to pass it off to Flavio, who's going to do our introduction.
Thank you very much, Jessica, and hello, everyone. I'm so happy to have you on this podcast, too. We have a number of great talks today. We'll go through those later, but I have a few things that I think are pretty good news for the community in general. The first one is that we have our 644 gold version available. This version, and this is the joke, it's not a silver or a bronze, it's a gold. This is really a minor release. It has a few bug fixes and a few enhancements, minor enhancements, but it should give you the latest and greatest version on the 6.4 line, while we continue to develop on the 7 line. So we'll have the 7.0 in the next few months. We also have a couple of important areas of interest for some of the community members. One is the summer internship. The proposals can start to be submitted now. We have now our student wiki online. We have a number of projects already there. As you know, the drill. If you are interested in any of these projects, please go there, get some of these projects on your little notepad and start maybe crafting an email explaining why you'd like to do this and how do you see yourself doing it and why you think you're good at doing these things, and send us a proposal. If you don't see anything that appeals to you and you still believe that there is something else that you like to do, please send it to us too. Let us know what you like. If you submit any ideas, we'll certainly consider them and add them to the ideas list too. So even if you end up not doing it, someone else may be able to do it. Now, the deadline is still a long time away. It's not until April 6, 2018. But don't wait for the last minute. Seriously. Don't wait for the last minute to think of what you're going to do. If you're planning on getting an internship, please start looking at it now. Use the little holiday time that you have upcoming, and really send us an email and let us know. Now, we also have now, and this is another important announcement, our recordings for our Community Day already available. And the Community Day has been great, and of course, thank you profusely our sponsors who have helped us put together that wonderful day, and every one of the attendees, even those that couldn't attend in person and needed to join virtually. But now all of those recordings are available, and I hope that you can go back if you have been there or have been listening live, and perhaps refresh some of the things that you've seen, perhaps find out if there are other things that could pique your interest, and or drill deeper in some of the topics that are there. I think there is plenty of good content there. I believe that many of these things are probably opening entire new domains for some people, and certainly if you find content that is appealing to you and you don't know who to contact because it's not clear in those recordings, just let us know. We'll connect you to the right people. And if you again find something that it's interesting and you want to get more comments around the community, please post in the forums, let others know, and you can make a little virtual meeting with the people that might be interesting as well. And certainly the poster competition was a great area of that community day, and we have also a recap of that. So on the screen you have now a link to that recap. If not, just go to our portal, and from there you can go to the recap for the poster sessions too. And we are already starting to prepare our next year community day. So this is we don't have any downtime here, and we are working quite hard to get everything organized again for the next year. So if you are interested in a speaking engagement at that time, and or you are interested in a speaking engagement in any of these download podcast series, and or you like to I don't know, write some materials, make something public or whatever, let us know, and we'll certainly get you engaged and involved. So anything that you'd like to do and we haven't thought about, let us know. Now, back to the content that we have today. I think you will be very pleased with the content today. We have two excellent speakers. One of them is a repeat speaker, Bob Foreman. You might be already familiar with him from his tips and tricks on Hpcc and some of the presentations on the lost lesson from the Bailey's site and other things. But also we have Robert Pelly. He is one of our architects in LexNext Resolutions. He has a ton of experience, has been around for a very long time in technology, been involved with a very number of very large-scale data warehouse projects and high performance systems, database systems. So I think he'll also give you a very nice perspective on a topic that should interest the majority of the people on this call. So please let me welcome these people, and let's get started then. Robert, the floor is yours.
Thanks, Flavio, and hello everybody. Thanks for joining. So by way of introduction, my name is Robert Pelly. I'm architect for LexisNexis Risk Solutions in UK and Ireland. As Flavio said, I've got many years of experience in the information technology industry in a variety of roles, and I've worked in prior to LexisNexis. I worked a lot with relational databases and helped design and build multi-terabyte data warehouses and other big data projects. And I began to find the limits of relational technology when it comes to really big data. You know, relational technologies just struggle when you go above a certain threshold. They struggle to deliver in query response times. And anyway, I started to look for an alternative, and I came to LexisNexis 6 years ago, and I've been working on a number of projects with the Hpcc systems stack since then. And yeah, so I'll go to my first slide. So the first question is, I'm here to talk about Redis and its integration into the Hpcc system stack. So Redis is an in-memory key value store, object store. So the first question is, are you familiar with Redis? Have you used Redis? So if you can take the time to respond to the poll when you get a chance, that'd be great. I'll give you a few seconds to do that. Okay, in the meantime, I'll move on to my first slide. Okay, this is the agenda or topics for my discussion. I'll go through them briefly before I delve into the detail. So the title is Redis Caching and Hpcc Systems, and I'm going to talk about the impact of rapid transaction growth in the UK HP systems environment, analyzing and understanding request duplication. I'll explain a bit more about what that means later. I'll briefly describe the UK HPC systems architecture before we implemented Redis caching, and I'll then talk a bit more about Redis caching and the architecture after we implemented Redis caching. Then I'll give you some brief details about our HPC systems and Redis server topology. I'll draw a few conclusions, and we'll have some Q&A at the end. So let's move on to the next slide. So this is a graph, and this shows the growth in transactional volume in the UK HPC systems environment. So it's hard to read the exact numbers, but I'll give you a brief flavor. Back in 2012, we started up and we were doing a few thousand transactions a day. By the middle of that year, we were up to several million. It's a pretty exponential growth. We peaked at nearly 16 million transactions in a day, and now we're pretty steady at somewhere between 10 and 12 million transactions a day. So it's pretty heavy traffic, and as an architect, one of my responsibilities is to make sure we maintain response times and give a good experience to the users of our systems. So anyway, moving on to the next slide. Okay, so the first topic is analyzing and understanding request duplication. In HPC systems, when a request for data enrichment comes in, there are two basic bits of information that go to help our HPC systems application handle that request. They are the request itself and what we call the context, which is the entitlement for the account holder. So it describes effectively what they can do with that request. So one thing that characterized the UK environment was a massive amount of request duplication. We knew that this was happening, but we'd never really fully analyzed the extent to which it was happening. So what we wanted to do was to find out, exactly how much duplication are we seeing and what can we do to help mitigate the effects of that duplication. So to do that, we used Hpcc. The application logging provides the raw data because every time we process a transaction, we log both the context and the request. So it's fairly easy to resurface the context and request data from the logs and to calculate the duplication ratios using ECL and Thor. And to do that, what we did was to genericize the context and request. What I mean by that is we would take out the transaction identifiers, the account identifiers, anything that made the context or request unique, but left in everything that was material to the processing of that request. And in doing that, we were able to calculate the incidence of what we would do. So we took the genericized context and request, and we derived the hash key. And then it's fairly easy with that hash key to analyze the incidence of request duplication within a configurable window of data. So you just put a filter on your log saying from and to date such and such, and then you calculate, you genericize your context and request, add them together as to make a combined string, derive a hash key, and then calculate the incidence of the repeats of those keys. And the results were that on average we found that requests were duplicated 4 times within a 15-minute window, with a maximum of nearly 350 times in a 15-minute window. So what we pretty much knew was happening, we were able to prove. We proved that there was a massive amount of request duplication. Moving on to the next slide. So before Redis caching, the HPC system stack, as it's implemented in the UK and in many places elsewhere, utilizes 3 levels of caching, and these levels of caching are focused on caching responses from data vendors. We have a long-term Roxy cache, which typically holds data for up to 30 days, a medium-term relational cache, which is pretty much a 24-hour cache, and a short-term cache, which is typically about 15 minutes. It's important to understand that these caches are for vendor responses, and the approach we took with Redis was quite different. So after we implemented Redis caching, we had this architecture. We now focused on caching the full multi-product response from Roxy queries. And what I mean by that is we could get a request for more than one product in a single transaction. And what we wanted to do was to find out if we could serve that entire multi-product response from cache if the request was a duplicate. So as I said before, Redis is an open source in-memory key-value object store. The HPC Systems platform offers a Redis Ecl plugin with publish subscribe functionality. I'll explain what that is in a little more detail in a minute. It has locking mechanisms to avoid race conditions. And as I explained before, the request and context XML can be genericized and hashed as keys to a Redis response cache. Now, what happens is, once you've taken your context and request, genericized them and built a hash key, you go off and look in your Redis cache and say, have I got that hash key in the cache? If you haven't, you use a method called get or lock string, and because it's not in the cache, it does a lock string, so it will lock that key in the cache, and then Roxy will go off and process the response. In the meantime, any requests for the same hash key will subscribe to that key, and they'll wait for a response to be published from Roxy. This is what we mean by publish and subscribe. When that response comes back from Roxy, it publishes the result and sets the new value in the cache. So that uses the set and publish string method. So those are the two key methods that you'll be using when you use the Redis plugin: get or lock string and set and publish string. Obviously, now that the value is set in the cache, any subsequent request for that cached value, that cached response, will just do a simple get. It won't need to lock again unless the value has expired in the cache. So now the full multi-product response is served from the Redis cache, and we've seen big improvements in throughput and response times, as well as a relief from the impact of duplicate requests. Okay, so here's a brief description of the topology we utilize in the UK. We've got a 4 times 20-way Roxy clusters, a Redis server with a primary and secondary node. A library called libhi-redis is implemented on every Roxy node so that Roxy can communicate with the Redis server. Replication between the primary and secondary Redis server nodes is enabled so that if one node goes down, we can fail over to the secondary node and the cache is still warm, it's kept up to date. To implement high availability, we use Redis Sentinels with automated failover. And what Redis Sentinels is doing is basically monitoring the health of the master and slave, and if it detects a problem with the master, it will promote the slave as the new master and then manage configuration to clients to say, you now need to connect to this one and not the old one. I won't go into too much detail about Sentinels, it's beyond the scope of this discussion, but there's a very good discussion of all of this on the Redis website, which is redis.io. And also we implemented the same stack in our disaster recovery environment. We didn't replicate between our production and disaster recovery environments, so that proved to be, it wasn't recommended. So, and because our cache window was only 15 minutes, we felt that if we failed over to DR, then it would only take a few minutes before the cache was hot again anyway. Okay, so that was the topology. Here's a few conclusions. Hardware upgrades can solve many of our performance problems. You know, we can add Roxy nodes, we can add ESP nodes, we can build out bigger clusters and more competent hardware, but it's important to remember that system tuning and software innovation can play an important role too. And as you have seen, caching plays a vital role in maintaining systems performance. We now cache at the full product response level, and we still use our legacy caches for vendor responses. The full product response, the Redis caching, doesn't replace the caching that we had previously. It augments it with a cache at the front of the application stack. So Redis caching is now live within our UK HPC systems environment, has been for several months. Redis is now handling the high incidence of request duplication. Duplicate requests are processed only once, and Roxy is freed from unnecessary repeat traffic, which is much what we set out to do. And we're now seeing that for some accounts, up to 70% of duplicate traffic is being served from the Redis cache. And that means that the response comes direct from cache, and all of the downstream, traditional processing we do, like cleaning addresses and getting hosted data and reaching out to data vendors and checking caches, internal vendor caches, none of that needs to happen. because the response can be served directly from cache. And we've also seen that an up to 80% improvement in response time, because where responses can be served direct from cache, obviously it's an in-memory cache, it's much faster. The open source Redis website, as I've mentioned, is https://redis.io, and there's a very good description of all of the commands and technology that you need to consider if you want to look at Redis in your stack. Okay, so the second poll question is, could you leverage Redis in your HPC systems environment? So if you could have a little think about that, and if you have a response, please respond to the poll.
All right, thank you so much. While Rob has an opportunity to look at some of the questions from the audience, we're going to go back and look at the results of our first poll, and that is, have you used Redis? And 81% of those of you online today say that you have, which is fantastic news. And approximately, it's the other way around. I'm so sorry. So 80% have not used it. So it still is fantastic news because you have a great opportunity here with what's been presented. So we're going to go ahead and take a peek at some of the questions. All right. So the first one is, how does Redis manage memory so that the cache does not grow uncontrollably?
Okay, I'll answer that question for you. Every time you set a key in the cache, you have the option to set an expiry. So when we set, because ours is a 15-minute cache, we set every key value with a 15-minute expiry, which means that after 15 minutes, it disappears from the cache. And then, so we'd have to reset it in the cache subsequently. So that's how the cache doesn't grow uncontrollably, because each cache entry expires after a configurable length of time.
All right, fantastic. All right, here's a second question. What hashtag function is used in ECL to derive the hash key?
Okay, that's a good question. In our implementation, where we genericized the context and request and added those strings together and then derived the hash key, we used the hash MD5 function to provide a hash key. So yes, it's hash MD5, an ECL function that's readily available.
All right, let's see. Here's one that just came in from the audience. How is Redis called in ECL? Via embed or direct function call?
That's a good question. Because sometimes since we wrote this code, and I'm going to have to defer that one, and I'll get back to with the answer. Can we have the name of can the person who raised that question reach out to me, and I'll give you full details?
Absolutely, I can get that information and I'll send it to you. And for those of you online, we will have it in our blog follow-up. Thank you.
Okay.
All right, so we've got the results from your last question here. And it looks like we've got 85% are saying yes, and 14% are saying no. So the question was, could you leverage Redis in your Hpcc systems environment? So excellent news.
Great, good to hear.
Yeah, that is. It's very good news. All right, so next up, it looks like we've got Santa Bob coming for us with a special holiday edition of ECL training tips.
So should I start with ho, ho, ho? Good morning, good afternoon, good evening, everybody, wherever you're at. Welcome to Tech Talk number 9. And again, my name is Bob Foreman. Hope everybody can hear me okay. If not, just somebody please come in and yell. The name of my talk is called the Bright Green Data Generation Machine, or affectionately known as Datagen. Now, this title I thought of as we were getting into this tech talk. I always get nudged by Trish and Jessica, and they're like, how about some tech tips this month? And so I'm thinking, what am I going to talk about? Talked about a lot of things over this year, and how are we going to wrap this up? How are we going to wrap this up with a bang? So as I'm going through, I talked to my esteemed colleague and mentor and manager, Richard Taylor, and he said, I looked at his code from several months ago when he first gave this to me, and I said, well, why don't we talk about this data generation? And inside this data generation machine, we can talk about an ECL tip using drill down. So that's the tip. The tip is the use of drill down, but coming along with it, I decided, well, why don't we, as a holiday gift for everybody, although we haven't even reached Thanksgiving yet, but this is our last Tech Talk of the year. As a gift to everybody, we'll give you this Datagen ECL bundle. It's actually starting to be put into a bundle, but it'll be a zip file that you can download, and very easy to install, very easy to configure, and I hope you have some use behind it. Now, my one challenge to those of you that are out there live is, what was the inspiration for the title of my talk? There is an artist that was behind this title, and if you want to put your name into the questions from the audience, followed by the name of the artist that inspired this title, then we're going to try to send you some nice Hpcc swag. So the first person that gets it right wins. So that's it. The question, first poll, not even a poll question, but what's the inspiration behind this title? And somebody remind me to give you the answer if no one gets it. So I think you have to be old like me to remember this. So anyway, let's proceed into our presentation. And our first poll question: do you have a need to generate random data of any size and structure in your everyday development? So is this a need of yours, generating sample data to test on your ECL processes before you decide to roll the dice and work on it with real data? All right, so while that poll is being answered, let's get into why we generated this or wrote this product called Datagen. I don't want to say product. This is a project that Richard Taylor had started on, and we had requests from universities, from people within our own community, of kind of a better data generation machine. And just to give you a history, I hope all of you out there know about the ECL Programmer's Guide and its usefulness and its wonderful tips and techniques that are presented there. And again, this was put together by Richard Taylor and, again, a number of other people, but pretty much Richard was the primary author of this. And as he was putting together these topics in the Programmer's Guide, he wanted to demonstrate a lot of the techniques in action. So he developed this program called GenData. So now you see where we're getting this Datagen. We just kind of flipped it around a little bit. The original GenData was a hard-coded ECL file that just generated specific files used for and dedicated to the Programmer's Guide. It was a single standalone ECL file, and if you take a close look at this slide, you'll see that it used a lot of sets of static data. It really didn't depend on anything external to the ECL code. All of the data that was involved was included inline to the GenData program. So you had sets of first names, sets of last names, sets of addresses, sets of city, state, and zip codes. And it was wonderful. And a lot of people have taken this and morphed it and changed it to suit their own needs. But Richard and the rest of us, we said, well, there's got to be a better way of generating data, a more flexible way of generating data. So the idea on the project for Datagen was created. So when we first started thinking about Datagen, there was requirements here. Unlike GenData, Datagen is an ECL code generation that uses a drill down technology that's been around the ECL IDE for many, many years, and a lot of people don't even know that it exists or they see it in a menu item and they go, I don't know what that is and I don't care. So we're going to show you what drill down does. It still works. It's still a staple in many uses. And in this usage of generating data, drill down was the savior for solving the problem that we were facing. The problem we were facing was the requirements here. We wanted to be able to generate any number of records, control it through parameters, generate any number of fields per record, support all the standard data types, and then provide standard data for typical fields like dates, names, lat, long, etc. And then also, since we were preparing this for use from some of our university people, they were doing some extensive work with machine learning, and they wanted to have a way of generating sample data for their machine learning and also come up with several different distribution types and test those distribution types and test their performance. So we also wanted to include that into our Datagen module. All right, so Datagen was born, and all you have to do is there's a couple of simple rules to install it and get it up and running. Number one, well, you need to have the machine learning library installed. So again, that's open source. You can go out to our Hpcc portal, download the machine learning library, install it into the ML folder, and you're off and running. Because in our Datagen, we use the distribution library of the machine learning part. Second, there's data files that we've already included in Datagen. Surnames, which in America we call them last names, male forenames and female forenames, again, male first names and female first names. These three files are all fixed length files, and they're each 25 bytes in length. So you will spray them. You'll upload them to your landing zone, then you'll spray them to your cluster, give them whatever name you like, and then you will tie them to Datagen via the parameter. Actually, I believe it's the input data set, source data set, SRCDS, is where you'll reference those particular file names. After you've sprayed the file, then you're going to take the datagen.mod file that's included in the Datagen zip file, and then import your code into your MyFiles default code repository, and magically it's going to generate two folders for you. One is called Datagen, the second one is called Drill Down, and they will work together. Now, you can install them into other folders if you like, but they have to be in some container root. So MyFiles is the default root, but if you had some other root folder that you wanted to install it in, you could do that. Just don't install it into a subfolder because of the referencing that's involved. So just by default, we're going to install it in MyFiles in this demonstration. And like I mentioned earlier, we added the source DS file to use the file names that you sprayed. All right, so once you've got your mod file imported and all your ECL code, once you've got those sample data files sprayed, then you're almost ready to get started. So the first thing you do is you open up the parms.ecl file that's in the Datagen folder, and you tell the Datagen how many records you want to generate, what's the name of your output file, and other things. Next, you go into another file called input.ds. You define the output file structure, and this is the exciting part. This is where you build your record structure. So you can move it around, you can add new fields to it, you can add as many or as little as you need. In input.ds, we have two examples that I'm going to show you. One is a record structure for the TerraSort benchmark routines that you run. The other one is just the simple sample data that I'm going to demonstrate. Next, we have just a sample container file called BWR test. Of course, you can create new BWR files to your liking and run any of the exported attributes or definitions that are in Datagen. And we're going to show you three examples of those in just a moment. Next, once you get your output of your BWR test, you highlight the entire result in the ECL IDE. You then right-click, and then there it is, drill down in your contacts menu, and then you select, well, there will be in the drill down menu option, because we have a drill down folder in the same container that we have our Datagen folder, magically the ECL IDE parses through that folder and then reads into drill down the names of the files inside of drill down, and we have a file already there for you called field type, which is a macro which does all of the heavy lifting and generates the data that you are desiring. So after you run your drill down, the drill down will automatically invoke a work unit, and the drill down work unit will return 2 results. Result number 1 will be a ready-to-go record structure and data set declaration for the generated data file. And result number 2 is actually the generated data file itself. Now, those of you that have attended my training, classroom training, or online training know that one of the things that we stress is you need 3 things to work with any data inside of Hpcc. Number 1, you first have to spray the data or output the data to the cluster. Then, number 2, you define the record structure. And then number 3, the data set declaration that tells the compiler where to find the file. So we've done that for you. We've generated the record structure and the data set declaration that you need for the generated data file. So to generate the record structure, again, you do a Control-A of result 1. You then just copy it to the clipboard, paste it into a new ECL file, and your record structure and data set declaration is ready to go. All right, so that's the mechanics of getting started with Datagen, but I'm not going to just slide you to death. I'm going to actually go out to the ECL IDE right now and actually show you Datagen in action. So I'm going to go with my screen share and then Alt-Tab over to my ECL IDE. There we are. So you should see my ECL IDE right now, those of you that are watching live. And what's the first step to all of this? Well, the first step to all of this is after you've downloaded the Datagen zip file and you extract the zip file, there is a file called datagen.mod. Prior to that, though, you also have to make sure that you have your machine learning library already installed and ready to go. So we're going to assume that you've already done that, and you've already unzipped the download file. And so from the ECL IDE, I'm going to go up to the top of my ECL IDE. I'm going to click on Open Builder, and there is my datagen.mod file ready to go. And so you see here that I'm going to just zoom in here so everybody can see closer. You have several files that are going to be installed in a default Datagen folder, including a very good and detailed README file. Thank you, Richard Taylor. And the second folder is the drill down folder that will do all of the heavy lifting and the actual data generation itself. So I've already done this. I'm going to go ahead and cancel this import because I've already imported it earlier. And as you can see in my repository, let me just open that up a little bit more and show you. There's 2 folders here generated. One's called Datagen, and the second one is called Drill Down. Now, in the Datagen folder, the first thing that you're going to do after you have imported the mod file, the first thing that you want to do is go into a file called source.ds. And in source.ds, here is the names of the files that I previously sprayed that's also part of the Datagen package. So if I go over to my ECL Watch real quickly, you'll see that I have 3 files here ready to go. There they are. And let me just zoom in on that so some of you can see it. So I've got Datagen test, male forenames, female forenames, and then surnames. So back over to my ECL IDE. There's the name of the files that I have on the ECL Watch. Ready to roll. There's string 25 once again. They are flat files. And so my point here is that Datagen is very configurable. You can add addresses. You can add city and state and zip codes. You can add anything you like to the Datagen package and make sure that you just spray them and so that the engine is able to reference these files appropriately. So this is one small part of it, and we're going to go into other parts that you would customize to add additional fields, additional data fields. Also, notice at the top here, we have a module called Word. So in addition to having external files that read sample data, you can also have, well, we have a file called setMod that has static sets just like we had in GenData. So you see here, here's a set of sample words that we're going to be using in our Datagen machine. So I just wanted to show you that in both aspects there, you've got the ability to access files externally through sample files or access direct data through static sets. That's all built into Datagen. All right, so I've identified the source of my data. I've got my mod file in place. All my ECLs ready to go. And so now let's start generating some data. So the first thing we're going to do is go into a file called parms. And here parms, I want to tell it, well, how many records per node do I want to generate? Interesting. And if you look at the code of Datagen, Datagen uses a very powerful form of data set that uses the counter, comma, transform structure. So the first parameter is how many records do you want to generate, and the second parameter is the transform that actually generates the data. So the default of that data set usage is local operation. So based on how many nodes you have on your cluster, in this example here, I'm saying, all right, I want 20 nodes per 20 records per node, and I've got a 3-node training cluster, so I'm going to get a total of 60 records generated by my Datagen test. Other parts of this parms is a random piece of the Datagen where we persist. Well, first of all, the persist prefix is actually used in our machine learning distribution area because some of these distribution techniques takes a little time to generate, so we persist them. So once they're generated the first time, the persist file will then restore them instantly. And I believe we have an expire set on these for 1 day. So you can use them during the day. The persist file will be up to date, and then if you run it the next day, it will regenerate these persist files. For random numbers, well, the story behind this is we have a random function in ECL. But the random function in ECL, we have no ability to see that random function, and the random function is not persistent. So we wanted to have the ability to generate random numbers that we could count on every time. So this UT random source file is the name of the random file that's generated on the cluster. I'm sorry, let me back up, that was incorrect. The name of the file in the cluster is this file right here. This randomness flag says, are you going to get your random numbers from a file that's generated or from a particular process, a field process? So we've chosen file as again, let me be more clear on this one, either file or function. So you can write a function to generate the random number, or you can just get the random numbers from a file. So as my next door neighbor and easy rider just rode by, some of you might have heard the motorcycle in the background. I apologize for that noise. Anyway, back to Datagen. These are the parms that you set up. We'll go back to our README file. So we've completed this step right here. The next thing we want to do is define our output file that's going to be generated on the cluster. So we go into our another module here called input dataset. And the file name that's generated, well, that was set up in parms. Let me go back over here again. That was the file name here that we generated. The input data set is the magic that specifies the record structure of the Datagen engine. So here we've got this data set called Gen Key, and as you see, the first line here is a numeric integer generating a unique ID, the technique of a unique ID. Now, you could generate other integers using other types of generation techniques like random generation and normal 2. There's also different types of dates that you can generate. You can generate a random spread of dates, or you can generate a sequence of dates from and to specified within a certain range and a certain default duration. So dates, numerics, and then here's strings. We have a default last name string, a default first name string, a combination of last name and first name, and finally, random words. And all of these field types are located in this module called UT for utilities. Let me open this up real quick, and I'll show you. Look at the configuration options that you have here. They're just amazing. A lot of work was done in this Datagen program. So you see here, there's our gen rec. You have your field types. So here you could add additional fields like address and city and state and zip. And for example, I added, I think, last name, and all I did was just look at the code that was generated and kind of copy and paste a lot of places, and then just emulated what was happening in the first name, and so I was able to generate last names very simply. So here's again last name and first name and full name, and you could add custom fields any way you want in this Datagen program. And here's our dates in the UT module. So rocking and rolling. This is just amazing to generate the code that you need. So, all right, so to summarize so far, install the mod file, import your ECL code, spray your sample data, identify your file names that Datagen's going to use, go into your parms file, generate the total number of records, your output file name, randomness. Input data set is how the engine is going to generate the code. Oh, by the way, one thing I really skipped here, I'm going to go back to it. Notice this is the code, the record structure for my sample data I'm going to demonstrate. But also down here is another sample record structure for, ta-da, the TerraSort file. So everyone talks about the TerraSort benchmark. How good is Hpcc with TerraSort benchmarking? So this was one of the things that we wanted to do. We wanted to demonstrate, to be able to generate and then test TerraSort benchmarking with a file that has the TerraSort data that's required. So we have built in the gen data another sample here that shows you how to generate a TerraSort file that's used in the TerraSort benchmarking. All right, so all the parameters are set up. All we got to do now is run it. So I'm going to go over to BWR test, and this code just has 3 simple outputs. The first output is a generation of random numbers to a particular file name that we're going to use, because some of the data that we're going to be choosing from will be using a random sequence, pulling in this first name with that last name and this number with this number and so on. So we use this random generator to control how our sample data is generated. I've also output the generate of the TerraSort record structure and then the generated key. So all of your sources of your drill down need to be referenced from the input dataset module, and then inside the input dataset module, you export the records that drill down will use. All right, so in the reference of, to save time, I've already generated this previously, and by the way, the timing wasn't that bad anyway, just to prove it to you. I'll go into the ECL watch right now real quick and show you how long it took to generate these 3 results. So come on, ECL watch, wake up. By the way, I am using the latest version of the ECL IDE 6.4.4, and I love it. All right, so the timing of those 3 results was total cluster time 0.286 seconds. So I wasn't really trying to pull any wool over anyone's eyes. The results were good. I just wanted to pre-generate them for you. So our first result here, random numbers, and there they are. And by the way, we wrote our own random generator using hash32 and a seed value because we wanted to be able to reproduce the randomness so that we could have consistency in testing and performance. Result number 2, well, this is the record structure for the TerraSort benchmark. And then result number 3 is our record structure that the drill down will use for our random data. So now we've got our template that we're going to use. I'm going to show you how easy it is. I'm going to do the TerraSort first. And all this is 3 string fields, 10 in size, name of the fields, and so on. I've got them selected right now. I did a Control A here to select all 3 records. I'm going to right-click, and down around the middle of the screen, you see a drill down option, and there is the name of the drill down that's in the drill down folder called field type. I'm going to execute that right now. So I'm now sending this content to the drill down code. It's submitting it as a work unit, generating it, and in just a few seconds, bingo, we've got our result. Here, the first result is the record structure and the data set that's generated for the TerraSort file. And the second result is the actual content of the TerraSort file. Ta-da! So there you go. Very simple, very easy to do. So, all right, that's our TerraSort stuff. Let me go ahead and close that work unit. And let me go back into our BWR test result. Let's go to result 3. And let's do the same thing for our sample data. Now, you see in our sample data, we've got a UID, a couple of date fields, last name, first name, and then different types of integers and a word string. Okay? So I'm just going to right-click on this guy. I'm going to go back to drill down again. Select field type. Now, be careful with this. Our field type macro is not built yet to support multiple sessions at the same time. That's why I closed the first one and then generated the second one, because your generation will always overwrite the first one. So, in other words, if I had left open my TerraSort result, you could overwrite the result of that generated file. So it's out on the cluster. It's fine. It's out there and saved. But if you remember in ECL lessons, there's something called hash unique name, and I'll probably be looking at that to add that to the macro generator to make it give it the ability to generate multiple sample files at the same time. Although that wasn't the intention. This is for just demonstration only. So here we are. Here's our second result. Here's the record structure. All right, ta-da. There's our UID, there's our last name, first name, record structure ready to go, and referencing the format of the dates that's supported in our date function, which are unsigned fours, by the way. And there's our data set statement at the bottom. So we're good to go. And then our sample data, there it is again. There's our sample words that we got from the static set. This is the last names that we got from our sprayed files. Here's one date type that's just a random date, and here's our uniform date that goes from a range to a range, and that's just controlled by a parameter. I think it's called size of 8, and you just say, give me a from and a to, and it gives you an inclusive range. It generates those fields automatically. So this thing is just rich in features, rich in things that you can do with it, and Richard Taylor and I, it's our gift to you. We're going to give you this code, and you can have at it and do what you want with it. We plan to eventually post it on Jira so that people can contribute to it if they want to do that, if they want to enhance some of the features of it. We have that plan to do that, and I'm going to talk to Richard about this just right after our presentation, and we'll get that thing rolling. The last thing I wanted to show you, which I haven't, it's our tech tip, is that actual engine of the drill down. So this is where I'm going to end up and wrap up right here. The drill down itself sends something called an XML row to whatever drill down target you have specified. In my case, it was called field type. The first thing we do is we make this XML row a variable length string. We call it myXML text. And then the template language requires load XML. Now, if all of this looks alien to you, let me give you a strong recommendation. We have an online course that's called Applied ECL, Automated Code Generation, and I have several lessons on template language, on macros, function macros, automated code generation. If you haven't looked at that course and you're interested in how we put this together, I will strongly recommend that you go out there and enroll in that course and take it at your leisure, at your convenience. So this macro generates two things. It generates a record structure and it generates an output string. We start the output string, we start constructing the output string by our import statement. So does this look familiar to some of you? Import std, import the Datagen folder. There is a line feed, new line, and then we start a record structure. And this code right here generates the record structure. So we look for the field type, we look for the field size, and we append, and we build ourselves a record structure. There's the end of the record structure and a couple of new lines to give us separation. And then the magic of the Datagen is right here. Here's our data set statement that's using, well, how many records do we want per node? Remember we set that to 20. And then here is the inline transform, starting the inline transform with layout. Well, by the way, where's the layout? Well, the layout was up here, isn't it? There it is. So there's our record. Now we're invoking and using that layout. And down here is the code that generates the transform. Self.fieldName is defined as your values, and we're using the counter of the data set to generate the randomness sequence of what values are getting selected. So this is generating the transform code. We then finish it up with the local. There it is, the local. That's why we said how many records per node. Now, if you wanted to do distributed, you could change that to distributed right here. All right? And then our last part of the append is to output this data set so we can actually see the records. So that was our result. And also the ability, well, after we append it here, remember, we're not really running it here. It's this guy right here. This one's going to output the record structure only, and then this one's going to output the entire thing, which is the record structure, and this output statement, which is going to generate the file. Woohoo! How about that? So that is packed with good stuff. There's a lot of things here, like the random function. You can look at how we generated random numbers, the variety of functions that you have here. Fantastic. And, just a lot of things going on here. So, all right. I think that's it for my demonstration. Let me get back over to my presentation, and let me get back over to the slides. So the live demo went pretty good. My laptop is not burning. And here's our last poll question. Would you like a copy of this code as our holiday gift for attending and watching this tech talk? So hopefully I'm going to get 100% yeses out there, those that are going to reply to that. Someone says no, I think they're just trying to poke the bear. So I think you want this code. I think it's good. I think even if you're not generating random data, you probably want to use it as a learning tool. So get those votes coming in. And Trish will make available this download if she hasn't already. It's probably out there already. And, well, let's see. What's the other thing I wanted to say? Yeah, I wanted to tell you now, well, happy holidays. And here's our email. If you have any questions on the Datagen code or anything in ECL in general, there's Richard Taylor's email. There's my email. And you see there I am on the left. We got Richard Taylor in the middle. He's our snowman because he's pretty cool. And I believe that reindeer on the right, that could be Flavio. I'm not going to mention any names, but happy holidays to all of you. Have a safe holiday season. Hope you come back in 2018 refreshed and ready to go. And that will pretty much do it for me. I'll open the floor to questions. Oh, by the way, real quick, did we get any answers to that question? What was the inspiration for my title, Jessica?
Yeah, we sure did, and they're answered in the questions from audience. We got several of them, so you'll need to look at those and tell us who was the first person to get the answer, or the first answer that's correct, and then I will go back and match it to the person who submitted it.
All right, so the first one, I don't know green title from Andy Farrell. So, I mean, that's got to be probably an Ireland thing that I don't know about. But the answer is the second result right there. Even though they spelled Garfunkel wrong, I'll give them credit. I'll give them partial credit for that. But it was Simon and Garfunkel. It was a song called "The Bright Green Pleasure Machine." And if some of you, I don't know how this is going to happen here, but we'll see what we can do here. See if you can hear this. Hold on a second.
So we had two people who answered correctly.
Data machine. There you go. All right. So that was the Garfunkel song.
All right, awesome. So we had two people that answered it correctly, and I will go into the system and find out who answered it correctly first, and we will be reaching out to you. So there are two of you, so very exciting. All right, so also, Bob, real quick on your poll questions. The first one was, do you have a need to generate random data of any size and structure in your everyday development? And 85% said yes. So fantastic. I hope that people have maybe learned something from what you just went through, so that's good news. And in terms of would you like a copy of this code? We are very fortunate today that no one's poking the bear, and everyone has voted yes. So what an awesome holiday gift from you and Richard. So there we go. And,
all right, and real quickly, Jessica, Jessica, real quickly,
I
apologize. Someone said my voice was fading in and out, so I hope that I was trying to keep my phone steady during the time. I apologize for that. Maybe someday we'll figure out how to hook up BrightTalk to my professional microphone, but hopefully everyone could hear most of the things I was talking about. I apologize for any of the voice problems. Okay.
Bob, I'll say that Trish and I were listening and we saw that comment come through, but you sounded very good to us. We didn't hear the modulation really, so I think it was probably fine. Anyway, that is all that we have for today, and we thank you all for joining us. Our next Tech Talk will be in January, and we're looking forward to having everyone join us then. We've got some very good speakers, and our own Arjuna Chawla will be joining us to talk about some of the trends in the big data industry that he sees. So that's a key one, and we also have a few other very good speakers already lined up. I believe Rodrigo Pastrana will be joining us, and Trish, who else? Okay, I can't think of them right now. So anyone, mark your calendars for January, and we'll see you then. Thank you so much.